Physics Penguin.
Hello and welcome to Physics Penguin's Guide to Pressure. In this video we'll be looking at the idea of pressure and seeing how it is calculated, as well as starting to see why it matters. Last week we looked at the idea of forces and discovered that forces can change how objects move or change their shape, or a little of both. Let's look at the second case. What if it snowed and then froze? The crispy snow could support the weight of a little creature like a pygmy shrew or a European water vole, a bank vole, a field vole, Orkney vole, narrow-headed vole, tundra vole, steppe lemming, or, of course, the Arctic lemming. Just look at these little furry things. However, heavier animals might fall through the surface and struggle in the deep snow. Heavier things like red deer, Curvus elephas, sika deer, Curvus nippon, fallow deer, Dama dama, roe deer, Caprellus caprellus, Eurasian elk, Alces alces, and reindeer, Rangifer tarandrus. However, reindeer do not normally fall through the snow despite being very heavy. Well, why not? Turns out they have special feet where the toes spread out to spread their weight over a wide area. In this way, they can walk over quite brittle ground. So the weight of a creature isn't the only factor in the effect of a force on an object. Force and area combine to give us pressure. Pressure is the force per unit of area. A high pressure means that a surface is likely to break or expand or pop. We can calculate pressure quite easily. Pressure equals force divided by area, so force must be pressure times area, and area will equal force divided by pressure. We're going to need these formulas, so try and remember them. The units of these quantities are very important. Force is measured in newtons, just N usually, named after Isaac Newton. Area is measured in square metres, although we often use square centimetres in practice. The unit of pressure is a bit more complicated. We officially use the Pascal as the unit, but the Pascal is also the same as a Newton per square metre. Pressure could also be measured in newtons per square millimetre, and there are even other units for air pressure and liquid pressure that we'll look at next week. Let's look at an example. Imagine a a Eurasian elk. It has a weight of 1,600 newtons and 4 feet, each with an area of 100 square centimetres. What is the pressure on the snow? Okay, well, pressure equals force divided by area, which is 1,600, the force is weight, divided by 400 square centimetres. And that is just 4 newtons per square centimetre. That's pretty low. However, this elk can't stand about all day. If she starts to move, then at least one of her feet will be off the ground. What will the pressure be then? Well, the weight is still 1,600 newtons, and the area is now 300 square centimetres. So 1,600 divided by 300 equals 5.3 newtons per square centimetres. That's still not an awful lot, but it has gone up quite a bit. Notice that pressure does go up quite a lot. This is because the area has changed too. This is quite important for shoes. If I am wearing my favourite Converse trainers, then the area of my feet will be about 200 square centimetres. However, if I'm wearing my stilettos, it's probably the weekend, then the area will be about 40 square centimetres. What's worse, when we walk, sometimes just our heels are in contact with the floor. This means that half our weight will be on the area of a heel, and that could just be 1 square centimetre. So if I am a 200 Newton penguin, then 100 newtons of my weight is spread over just 1 square centimetre. So the pressure there would be a massive 100 newtons per square centimetre. This is why the National Trust have rules about not walking around on all wooden floors wearing high heels. They're also not very keen on letting penguins in. Let's try a worksheet to see if you can work out the calculations for yourself. You can download the questions from the link in the video description and have a go. Then check the answers in the last part of the video. Pause the video now. Welcome back. Let's have a go at that worksheet now. Question 1 is about the formula for pressure, so we just need to quote what it is. Pressure equals force divided by area, so that's it. Question 2 is a reference to a song that we certainly don't have rights to play a clip of, but it goes a little bit like this. Dub 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 under pressure. Yeah, okay. Well, let's take that copyright material. Now the calculated bit. Pressure equals force divided by area, which is 600 divided by 0.06, which is 10,000 newtons per square metre, or 10,000 Pascal. That really is quite a lot of pressure. Pressure can get very high quite easily. Did you know that legend has it that samurai swords were so sharp that if you placed one by the handle in a stream with the blade facing the water flow, it could cut leaves as they floated into it? If the edge area is very small, pressure gets very high. Question 3 is another pressure calculation. We have a force of 100 newtons spread over 5.1 square metres. So that is 100 divided by 5.1, which is 19.6 newtons per square metre, or 19.6 Pascal. Since this is less than the 22 Pascal needed to break the window, that means that the window is safe. Question 4 is also about pressure, but we want area this time. Pressure equals force divided by area, so area equals force divided by pressure, which is 200 divided by 250, which is 0.8 square metres. And question 5 is the same formula, but we want force this time. Pressure equals force divided by area, so force equals pressure times area, which is 30 times 5, which is 150 newtons. Sweet. Hope you didn't feel under too much pressure today. That's it for Physics Penguin for this week. Please subscribe to keep informed of what's going on, and I'll see you next time. This is Physics Penguin saying ta-ta.